First, we will analyze what is BCD addition. You might have studied in digital electronics. Now, if the first example, if I am adding the 36 with the 29, then this is the answer in the BCD. BCD is nothing but what? Binary coded decimal. This is a decimal value we are getting. But when you give these values to the microprocessor will add the numbers like this and it will give the answer like this. Now, how to convert this hexa number to the BCD number means, so whenever if lower nibble or higher nibble means what? Lower 4 bits or higher 4 bits. If any value is greater than 9, then there we need to add 6, thereby what? We will get the BCD number. Now here in this case, if you see, by adding, we are getting the 5F. Now F is greater than 9, so we need to add 6 to the lower nibble. By adding 6 to the lower nibble, we are getting the decimal equivalent value. Now see here and here, both the answers are same. Now coming to the second example, if I have taken the 38 and 29, answer is 67. And this is a decimal addition. Now processor will give the result when I take the binary value of this and binary value of this and after addition. So processor gives this result in the accumulator. But if you see here 6 is greater than lesser than the 9 and 1 is also lesser than the 9. But this answer is not matching with the decimal value. Why? Because here auxiliary carry is generated. Means what? From the lower nibble to higher nibble, auxiliary carry generated. So because of this auxiliary carry, it is not matching. So here also, whenever the auxiliary carry, if the lower nibble is greater than 9, we need to add the 6. If any auxiliary carry is generated, then also need to add 6. Then by adding 6, we will get the correct answer, decimal. Now here you can see the decimal answer is this. After adding the 6, we are getting the decimal answer. Now coming to the example 3, I have taken the 60 and 70. If I add these two, I will get 130 in the decimal. But if you give this value to the processor will do the addition and give the D0H. Now here if you see, higher nibble is greater than 9, lower nibble is less than 9, but higher nibble is greater than 9. To get the decimal BCD addition, so BCD value, so need to add 6 to the higher nibble. So now here added the higher 6 to the higher nibble, thereby what? We got the 130. Now carry generated, that carry I have taken here. So 1 is the carry and 30 is the 130 is the answer. Now in the fourth case, if you see, this is 90 and 80, my decimal addition is 170. But if when we give this number to the microprocessor, it will take the binary value like this and will add and give the 110. 1 is the carry and 10 is the result which is available in the accumulator. But if you see here, 1 is lower than the 9 and 0 also lower than the 9, but this answer is not matching with the decimal. Why? Because here the carry is generated. So where the carry is generated, for that needed to be add the 6. Now here the carry generated from the MSB. So need to add 6 to the higher nibble. Thereby we got the decimal value. Now here in this case, what you understood, so whenever we need to do the decimal addition, BCD addition, so if you wanted to check the result in the decimal form, then 4 conditions are there. One is, if your lower nibble is greater than the 9, then need to add 6 to the lower nibble. And the second condition is, if the lower nibble is not greater than 9, but still if the auxiliary carry is generated. So in this case, condition 1 is what? If lower nibble is greater than 9, need to add 6. If auxiliary carry is generated, need to add 6 to the lower nibble. And condition number 4 is what? If higher nibble is greater than 9, need to add 6. If carry is generated. Now, if the MSB bit, if any carry is generated, that we call it as a carry. If the carry is generated, then need to add 6 to the higher nibble. Thereby, we will get the decimal equivalent value. That is the, in the case of BCD, this is the BCD addition which you have studied in the digital electronics. Now, in a microprocessor, if I wanted to write the program for the BCD addition, means what? If I give the number which are lesser than the 9 values, if I give, then I should get the decimal. I wanted to check the decimal result in the decimal form. For that, there is one instruction. That instruction is called the DA. So instruction is what? The decimal adjust after the addition. Now this is DA instruction, which is if we use this DA instruction, this instruction itself convert the hexadecimal to the decimal. Now how this conversion we have done manually, this everything will be done by the DA instruction. DA itself will do all these things. It will check lower nibble. If it is greater than 9, then it will add 6, and if auxiliary carry is generated, it will add 6 to the lower nibble. If higher nibble is greater than 9, it will add 6 to the higher nibble. If carry is generated, it will add 6 to the higher nibble, and it will convert the hexadecimal to the decimal uh, value. So this is about the DA. DA is very, very important instruction. Now how to write the program for the BCD addition means, already you know that writing the program for the 8-bit addition. Now same you have to write, and also this DA instruction only we have to use after the addition only. So after doing the ADD, ADC, ADI, so any addition instructions are there, only after the addition instruction only we can use the DA instruction. Now how to write the BCD addition for the 2 8-bit means what? First, if I'm taking the location 6500, so and 6501, here two numbers are I am storing. So same it is like a normal addition. Now for this what I am taking the for carry, to check the carry I am initializing C register to the 0, and here this in this location I have moved the data with whatever the data. Now in these four examples, any one of the value you can take. So this I have to initialize with the HL pair, HL6500. Now after that what, move one of the value. Doing addition means what? This we have to do, we have to use after the addition only. So doing addition means what? One of the value must be in the accumulator. That's why what? Move A comma M. So this value, first value moved. Now for example, if I'm taking the 70 and 80, so this value must be in the accumulator, and after that increment the HL pair so that it is pointing to the next location, and this value is needed to add with the accumulator. So we can use add M, means what? This value is added with the accumulator value. Now after that we need to convert the whatever the number. If it is a decimal form only, if it is now if you are taking the 20 and 30, now in this case if you do the addition you will get 50. Now if you give these values to the processor, then also processor will give 50. That time DA will not do anything. So it will check the result. If values are lesser than 9, if any carry is not generated, DA will not add anything. If the values are in this case, if these conditions are raising, then only it will add 6 and it will convert that value into the decimal number. And after that, we need to check any carry is generated or not. If the carry is generated, then we need to store that carry into the C register. Otherwise, no need to. If carry is generated, that we have to store it into the C, means what? INRC. If carry is not generated, then simply store the result. For that, what we need to do, so result is what? In the next two consecutive memory location. Now here we need to add the accumulator value. Here we need to add the carry value. So need to increment and move M comma A, and once again increment the location and move C M comma C and halt. Now, if you observe this program, this is nothing but a 8-bit addition only. Only this DA instruction is added extra. So, to convert the hexadecimal value to the decimal. If add instruction itself is giving the decimal value, that time it will not do anything. If it will check these 3-4 conditions. If any condition raised, then it will convert into the decimal. And now we are going to get the value. Now 70 plus 80, if you add, what you will get? So 0, and here it is 15. So carry will be 1, and here you will get the 50. So this is about the BCD addition. Only the DA instruction you have to add. And what is DA instruction means what? You have to explain this. So DA will convert these 4 condition. Any 4 condition rise, then the DA will add 6 to the lower nibble or higher nibble depending upon the condition raised. So this is the BCD addition. Now we will see the 16-bit addition. Here we have seen the 8-bit addition. So now how to do the 16-bit addition? If you see all general purpose registers are 8-bit length, then how to perform the 16-bit addition means, so now here this is the first value, lower value is 01 and higher value is higher byte is 23, and here lower byte is 645 and higher byte is 76. Always remember that lower byte will be loaded into the lower location, higher byte will be loaded into the higher location. Now I have to assign this value to the HL, and I have to assign this value to the now HL. First now let me check what is the instruction to load these two values into the HL pair. For that, I have to use LHLD. Now here I am not using the LXI. LXI means what? In a H and L, you are moving the location values. But now here LDX means what? So first location value is moved into the L. This is moved into the L. And second location value is moved into the H. LHLD means what? uh, Loading the HL register pair with the address location which is specified here means what? In this location, whatever the data is there, that is moved into the L, and the next consecutive memory location value is moved into the H. Because HL is a 16-bit pair, automatically it will take the next location, consecutive location. Now in the HL, in the L01 is available, in the H23 is available. So now this data is loaded into the HL. Now what we need to do, we need to store this data into the DE register. For that, what XCHG instruction I am using. So now this I am moving into the DE register. How can I do? By using the HGXG. What HGXG will do? It will exchange the HL register with the DE value. So now whatever the value is there in the HL, that is moved into the DE. Now these values are in the DE. Now here these values are, earlier it is in the HL. Now after using the exchange, DE is holding this value. Now after that, what? Once again need to send these values into the HL pair. For that, what? LHLD 6502. Now this location is what? 02. So if I mention 02 means what? 02 will be loaded into the L, and the consecutive memory location, next location 3 will be moved into the H, because HL is a 16-bit pair. Now after this, now this second value is in the HL. Now the second value is in the HL and the first value is in the DE. So both 16-bit data can be added by using the one instruction, that is nothing but what? DAD-D. So this is a DAD-D. This will do the addition of HL with the DE. Now here I have mentioned the D, that's why it will do the addition with the DE. If you mention here B means what? BC. So if you mention H means what? HL with HL only. But here exchange, I can only do the exchange with the HL with the DE. That's why I use the DAD-D. DAD-D means what? It will do the addition. Whatever the register pair you have mentioned here, that register pair will be added with the HL, and again result will be loaded into the HL. Now where the result is? Now this is the DE value, this is the HL value. After the addition, the result is in the HL. Now this result I need to store it into the next consecutive memory location. Now for that I have one more instruction, SHLD. Store whatever the location you are mentioning here, store the HL values into the two consecutive memory location what you have specified. Means what? L is moved into the 6504 and H will be moved into the 6505. Lower will be moved into the lower location and higher will be moved into the higher location. Now this is the 16-bit addition. This question also came in the theory exam. So now I hope you understood. Here this is a new instruction, this is also new instruction, this is also new instruction, this is also. Now 4 new instructions we have used here. This is about the 16-bit addition.